Okay, we need help by some technician because I do not know where is my slide. This is very nice, I would say. Good evening to everybody. And it's very nice because it tells you that we are using really Stone Age devices. These are very, very rigid devices. If something does not work, nothing works. So this is exactly the opposite of a living system. So, I mean, these difficulties which are here, which could be embarrassing, actually tell us something very important. Living matter, biological systems, are not like computers. Absolutely. Today, of course, there is a large propaganda, a lot of information, big business about machinery, about computers, informatics. I mean, we could not live without our mobile phones. However, okay, thank you. This is the first page of my talk. However, we are much, much more different than these objects which are around here. Where is the difference? The difference is, let me introduce catchwords. I have not much time. I ask you, please, tell me when I have 10 minutes, okay? So I just will tell you something. I will give you an idea of the many things I would like to tell you. But some word is important to have. One of these words is coherence. Coherence is a typical word which we use in, this is another catchword, in quantum field theory. Notice quantum here is attached to the word field. So we have fields. We have infinitely many degrees of freedom objects. This is like saying how many particles of air are in this room. Many. We cannot count because windows. So we cannot think in terms of single particles. You see, this is crucial to physics. We only can think in terms of collections, of large numbers of elements. So we talk of fields. A field has to do with a system made by large, very large number of, we say, degrees of freedom. Degrees of freedom, it means that something is free to do something, let's say, more or less randomly. But this word randomly brings us to another catchword, which is symmetry. Symmetry is something which usually is understood to be related with beautifulness. But from the point of view of what tells us is not satisfactory. What we talk about in physics is a breakdown of symmetry. You see, if something is symmetric, you can move it according to such a symmetry and the system does not change. If you are in a square from where several rods go out and there are no signs, you do not know where to go, which one is your way. So to know which one is your way, you need some arrow, some signal, which tells you that way is Paris, the other way is Naples. I came from Naples. When you put such kind of arrows, such signals, you break the symmetry. So you get an information. So you have a breakdown of symmetry. In quantum field theory, what today we study, since already several decades, is the phenomenon of spontaneous breakdown of symmetry. Out of the spontaneous breakdown of symmetry, the dynamics, namely the rules which govern the behavior of the elementary components of a system, creates some beautiful things which we call long-range correlations. Let me give you a metaphoric description of this. We are all in this room. Each of us came by using a car, a bus, something like that. And we are talking by using our voice, amplified by this instrument, okay? This is a short-range interaction. We have a problem if this microphone does not work in talking. This is a short-range interaction. But we are able to talk each other. As a matter of fact, I'm sorry I'm talking to you, but you please interrupt me anytime you want. To talk, being nearby, because we were brought here by some long-range interaction. Which one is such a long-range interaction? Is our common interest in the subject of this colloquium. This is the long-range interaction. Even after this colloquium, when we go back home, each of us, we are still related by such long-range interaction. This is what we are talking about. And in physics, the idea that we have of a living matter, I think is in the title, I talk of living matter. I could have been writing biological systems or living systems, but since I am a physicist, I know matter which is in its different phases. You know, liquid phases, water, or ice, solid phase, or vapor, gases phase. But there is a phase of matter which is a living phase of matter, when the matter starts to be alive. This is a challenging, a really challenging problem for a physicist. And this problem, the approach we use to study such a kind of problem is not something which is just from physics. Knowledge is only one. There is no separation between physics, biology, chemistry, whatever. Knowledge is only one. And this is our main powerful tool. We can talk. I talk with Professor Montagnier, with Cedric, who is a mathematician, because we share such a feeling. We talk of things which are there, and will be there even if we are not talking or no more there. I said that the world was the same before and after dinosaurs. So our interest is in the study of nature. And this can only be a unified study. Of course, there are different methodologies, and these are different, but the object, knowledge, is only one. So, if we would be here talking about some problem, I don't know, in some part of the world, as at UNESCO is normal to do, I could write in Arabic symbols, something. And you will not be scared. If I came from Greece, I could write in Greek symbols of the Greek alphabet, or in Cyrillic. So you would not mind if I write in symbols which are mathematical symbols. Mathematics is a language. I see someone smiling and just thinking, now I go away. You can do that. But why? Why you should be scared by playing around with such beautiful symbols which are once used by mathematicians? I'm a physicist, but of course there is no physics without mathematics. And even if Cedric Villani will say maybe something against, I would say that there is also no mathematics without physics, but we can discuss that. We can discuss that. In any case, what I'm showing you is up there. That is a coherent state. Is the mathematical expression, so a symbolic expression, of what we call a coherent state. So let's read that formula. You see, at first, before t equal, there is no pointer here, but this object here, alpha, that one where I put, okay, doesn't matter. before just starting the line, that alpha, that symbolize all what is written on the other side of equal, okay? Now you have those first symbol, and then you have all this zero with that kind of arrow, and then you have a next one, you have a 1, forget about the alpha in front of those. And then you have 2, you see, in those symbols. It's a pity that, you see, these 2, you can see here, and then you have 3, and then you have n. And then you have equal to such a sigma, which means summation is just, it means what is written on the first line, adding up all those pieces. Summation, but you see there is something very important. That is a summation from n going from 0 to that symbol, which is the way we write infinity, this symbol here. Okay? So you have to sum infinitely many pieces of that kind. So you have infinitely many n, what is n? The number of objects which are in all these boxes. So here there is no object in this box. Here there is only 1. Here you have 2 of them, and so on. You have infinitely many, so you deal with the field. You see, I'm talking of a quantum field theory, but please notice, this is not quantum mechanics. Quantum mechanics is another story. Quantum field theory is dramatically different from quantum mechanics. So if you use quantum mechanics to do what we are doing, you will not get anything good out of it. You need quantum field theory. Quantum field theory you might think as an evolution, as a dramatic, completely different stuff with respect to quantum mechanics. People today is still thinking in terms of quantum mechanics, but quantum mechanics has a lot of applications still to be done today, but as a theory is finished, its end is in 1930 when Paul-Maurice Dirac wrote his equation, and it was discovered that we do not have one electron. We cannot think in terms of 1 or 2 or 10 electrons, but we have to think in terms of a field of electrons. So when we say, as a physicist, the electron does satisfy and so on, we mean infinitely many electrons. This is the concept of field. And the consequences are strikingly different from what you have in quantum mechanics. This object, if you do not sum from n to infinity, does not give you the beautifulness I'm going to tell you. So you are summing. Now in front of each of those boxes, there is alpha to some power. Alpha to 0, which is just 1 in front of this 0. Yes. Here there is no alpha, because alpha to the 0 is 1, so you have 1. Here you have alpha to the power 1, so it's not written. Here you have alpha to power to 2, and so on, power to 3, and so on. Now this alpha, this is a complex number. A complex number is nothing special. It's a couple of 2 numbers. It's made normally, this is a jargon we use in mathematics and in physics, by something which you call the modulus. And a phase is written here. This theta is the phase, and this alpha with this straight line is the modulus. Now you see, all these boxes have the same alpha. In that alpha, there is the same theta. This is coherence. Coherence is to be in phase. When you listen to a concert with a very big orchestra, I don't know, Boston Philharmonic or something like that, there are even hundreds of musicians playing, but you do not listen to each one of them. You listen to the orchestra. The musicians belong to the orchestra, but the output is a collective, is something which belongs to the collection, to the orchestra indeed, to the collection of all of them. So the coherent states as a property, which are not the property of one particle state, of two particle states, of 1,000 particle states. No, as a property which is the collection of infinitely many particle states. And the sum of all of them. So you see what happens. Because of that shape, that mathematical shape, you can pull out one particle from each state. So from 0, that one will disappear. There is no particle there. But from 1, you take one particle, and then that one becomes the 0. Okay? You have a box with one particle, you take it, the box becomes empty. The first box, 0, means that you have an empty box. So if you pull out one particle from each one, you have a rescaling of all the system. The beautifulness consists in the fact that the whole system reconstructs itself, and you have the same object as you started with. I used to say that this is like a necklace with infinitely many seeds. If there are many, very many, you can take one and you will not even notice. So the necklace will not change. If you have 10 and you take one beautiful pair, 10, you will remain with 9. And if you do it again, it will become with 8. But if there are infinitely many, the necklace will be always self-similar, will be always the same. You will not realize that you have been taken out one seed or two, or even many. Since infinitely many is something which is not countable, you can take infinitely many of them. And still you remain with a necklace. What we are talking about? We are talking about the robustness of coherence. Coherence is a very robust business. You see, your brain is very attentive, and you may have, you are sustaining your patience, with patience, what I'm saying, listening, and this is the stability of how your brain works. How it could work, your brain, in a stable way, if not being a coherent state system. This is why you need the fields, to explain one of the main properties of living matter, its stability. You see, fortunately, it's very difficult to kill somebody. Life is very difficult to be destroyed, because life is very robust. In this way, we describe such a robustness. But life is also changing. So the best of it comes when you have transformations. Biologists teach to physicists that the living systems are far from the equilibrium systems. A biological system at equilibrium is a dead system. Please be alive, be changeable. Don't be, if I can say that, conservative. Otherwise you will be dead. But I think I have to stop. Nevertheless, I told you two elements, two things. One, the need to describe a coherence of living matter. Of course, when I say living matter, I'm talking also of DNA, but we will have many talks after mine about the DNA. And I told you about robustness of coherence, namely a property of a living system. And I told you also about oblivion. This meeting, the word memory of water, memory of something, is in the air. But I do not like to talk about memory, because if we would be with stable, permanent memory, we would be like that character by Borges, Mr. Funes. He was remembering everything of everything. He could not live. He could not be alive. What we need is oblivion. Oblivion means that we had to learn something, otherwise we cannot forget about something which we did not learn. So we need memory, but the best of the living matter is oblivion. We forget things. If we would remember every single word when we talk, we would not be able to talk. So we need to forget. And it's beautiful that forgetting means also to forgive. So we forgive at every step of our life what comes through us. And this is life. Life is resurgent continuously out of a memory treasury. But such a treasury is useless if we cannot forget. So this is the beautiful property, going into the detail of this meeting, of water. To a physicist, water is a collection, a field of dipoles, electrical dipoles, because the water molecules is H2O, as everybody knows. But the two electrons of the two hydrogen atoms, they like to spend their life nearby the oxygen. So around the oxygen you have a majority negative charge. And around the two hydrogen atoms you have a positive charge, just because the negative one is moved. So you have an electrical arrow, like a compass, like a magnetic needle. This one is an electrical needle. And they can be oriented in each direction you want. But if there is an external disturbance, you might orientate all of them in some direction. Fortunately, for a short time, because you need that they forget the direction you give to them. So water is what realizes such beautiful compensation between ordering, giving an ordered pattern, and cancelling, forgetting, oblivion. But now I must finish, because otherwise my chairman will kill me. Thank you.